All right, good. Corners in progress. Here we go. So here's what I do. I'm gonna make a box. I'm gonna do 4 columns because I have degree 4. I'm gonna do 3 rows because you're dividing by x squared minus 1. So you have to write like this: x squared, 0x, and negative 1. And you put 3x4 right here. Okay. What do you multiply x squared to get to 3x4, guys? Good. And then if you were to fill out the rest of the boxes in the first column, that would be 0x cubed. Correct, 0 also, that doesn't matter. And negative 3x squared. Okay. Let's look at the numerator. What's the coefficient of x cubed? So you need this to be negative 2x cubed. Because 0x cubed minus 2x cubed is negative 2x cubed. So this becomes negative 2x. So you get 0x squared and positive 2x. All right, now we go again. Do we see an x squared here? No, right? I don't see an x squared. So what do I need to have? So you have to look at these through diagonals. What do you combine with negative 3x squared and 0x squared to get to 0x squared? You need 3x squared. See how all those will cancel along the diagonal? So then what goes up above? What do you multiply x squared to get 3x squared? 3. Okay, it's looking pretty good. So that becomes 0x and negative 3. Now, we don't see any x's at all, right? So it should be a negative 2x, right? So I'm not going to really do much about that. Also, I see a negative 3, but there's a positive 2 here, right? So what do I add to negative 3 to make it positive 2? And that's your remainder. 3x squared minus 2x plus 3 plus negative 2x plus 5 over x squared minus 1. So this is a process that I think is pretty neat. It works really nicely as long as you get the hang of it. I feel I did a much better job explaining it to you right now than I did 2 days ago. I was a little rusty because I haven't taught in like 3 weeks, right? So anyway, I can try one more if you guys want to see it in action one more time. Or do you think let's do it one more time? Let's go back to the notes where I screwed up the notes. So let's do it one more time. Before I do that, complex numbers are cool. Any questions on the complex number stuff? Part C, that made sense. Part D. Plot form, you guys are cool with? Okay, I'll come back and do 11 and 12 with you guys in a moment. Let's go back to the notes because I kind of screwed that up. All right. Let's try it one more time here. All right. So guys, remember what the answer was for this one? What was the answer for example 5 on page 7 of the notes? You guys should have your notes. Do you guys remember? Or do you guys have someone tell me? Okay, well, I remember this, but someone tell me. X minus 3, yes. So we expect x minus 3 to be my final answer, right? Okay, here we go. So x squared, 0x, and 1. And I'll put x cubed up here. Okay, let's not worry about the lower right corner because things can get weird with the remainder. So you put the leading term in the upper left corner. You put whatever you divide by off to the left. And any term that got skipped over, like there's no x, put 0x as a placeholder. Okay, what do you multiply to x squared to get to x cubed? X, right? So it becomes 0x squared and x. Now, I do see negative 3x squared. What do I combine with 0x squared to get to negative 3x squared? Negative 3x squared, right? So it becomes negative 3. So then you get 0x. And I did too many columns, so that's okay. And that's negative 3. Actually, I think I'm okay with the columns I have. All right. Cool. Now, I do see an x. So everything is fine. I do see negative 3. Everything is fine. So there you go. It's x minus 3. Done. There you go. So I didn't need to fill out the other columns because everything inside combines what I have in the numerator. I needed x, I already have an x covered, x and 0. I need -3, I already have a negative. I don't need to put anything else into the columns because I have everything I need. Let's do it one more time. Let's look at example 6. Okay, can someone tell me the answer for example 6? What was the answer for that one? I'm sure someone had it. Example 6. Okay, I'll just pull up, guys. Did we not do example 6? Guys, did we not do it or no? Okay, tell me. Oh, so did I mess it up? Yeah, thanks. All right. Okay. Hold on. I'll pull it up here. Here's the answer. Okay. The answer is supposed to be that. Okay. That looks kind of crazy, right? Let me show you that box method again. Okay. Yeah, I know. Okay. Well, I'm gonna do 5 boxes, sorry, 5 columns still. So 1, 2, 3, 4, 5. Okay, I have 2x plus 1. You have 4x5. Okay, now let's get moving here. What do you put up top here, guys? 2x what power? So that's 2x4. Now, do you see it an x4 in the numerator? So you put negative 2x4 here to cancel it out. Now, what do you multiply 2x to get to negative 2x4? Good, thank you, Thomas. Let's get negative x cubed. Do I see a negative x cubed? I do. So that should just be 0x cubed. I don't need to put another x cubed there. So that's going to be 0x squared. That'll be 0x squared here. So even though it's kind of redundant, let's do it anyway just for the sake of the placeholders. Now, what do you add to 0x squared to get to 2x squared? So this has to be x. So that's x. Now, we have negative x. What do you add to x to get to negative x? Negative 2x. So it becomes negative 1. And that's negative 1. However, we want 0. Right? We want 0. Because remember, there's nothing there. So what do you have to add to that to get to 0?
1.
Right, you must have 1. So it's going to be 2x4 minus x cubed plus x minus 1 plus 1 over 2x plus 1. And if I look at the answer key using long division, yep, that's exactly what I get, 100%. So if you want to use long division, you can, but I think this is a technique that kind of just organizes things much better. As long as you just follow the procedures, you'll be fine. Zay, go ahead. I'll go back again. Okay, so everything so far, you're okay with how I filled the boxes?
Yes.
Okay, so when I got to this point here, right, at x, okay, so I needed a negative 2x. This had been negative 1.
Yeah.
So 2x times negative 2x, 1 times negative 1 is negative 1. But there was no constant in the numerator. So you assume the constant 0 as the last term. So I need 0 as my last term, but right now that's a negative 1. So what am I going to add to negative 1 to make it 0? 1. And that's your remainder. That's how it works. So sometimes we do add like an extra column just to kind of finish it off. If that makes sense. So yeah. All right, cool. All right, I think we're all set. Okay, so go back to homework one more time. Let's show the answer keys, sorry. Okay, for 11, you guys are cool with how that looks. X-intercepts are 0, 3, and -2. There's a bounce at -2 because of the square symbol. End behavior is up because you're at degree 4, positively in coefficient. Everything seems okay in that regard. Now, will you be able to know like where this peak happens or slow point? No. I've not taught that to you guys yet. You can do some Desmos or graphic calculator to figure it out. The way you're going to do this analytically is not until next year to get to calculus. I will teach you the skills in calculus. It's called a derivative. I'll teach you those skills. I don't think we'll get to that point where we're gonna figure that out in the semester. If I have time, I'll try to do it. It's a really neat thing to do. But I haven't taught you guys how to find out precisely by paper or by hand, because that's calculus. We're not there yet. So for now, just x-intercepts and behavior, y-intercept, bouncing, crossing, just make sure you're cool with that. Okay, 12. It's very factored for you. X, y-intercepts are pretty easy. Vertical asymptote is pretty easy. The horizontal asymptote, now someone was asking about, like Thor, you're asking about this. When the degree of the bottom is higher than the top, and I'll give you guys, I'm not going to provide it on a test, but I'll summarize it for you in the notes when we get there. Yeah, when the degrees of the bottom is higher than the degree of the top, it's y equals 0. Now, this answer key looks kind of weird. I haven't taught you guys to do it this way yet. All I really want you to know is how to write the limits. Like, oh, so that's approaching negative infinity of the expression. Then you want to say it's 0. Just say it's 0. You don't have to do this algebra because I haven't taught that to you guys yet. Very premature. We will do this. We'll do this in spring. But just say it's 0 in each case. Just tell me what the horizontal asymptote is. The horizontal asymptote is the end of 8. They're the same thing, right? Because the ends of the graph is horizontal asymptote. So just write the limit. That's great. But just say equals 0 and equals 0. You don't have to do all this stuff here because we haven't done that yet. Okay. Sign chart. When you do a sign chart, you have to look at what makes both top and bottom 0, because y equals a bunch of multiplication and division stuff, factors. So you have to also look at what makes the bottom 0 as well. So x-intercepts and vertical asymptotes. And yeah, just test the far right interval like 5. You see y is positive. Because every factor occurs once, you're going to see an alternation in signs. So great, do alternation signs and you're good. And then whatever's positive is above the x-axis, whatever's negative is below the x-axis. Because what you're doing is you're telling me where y, you're doing a sign chart for y, where the y is positive or negative. Y is positive above the x-axis, y is negative below the x-axis. That's what a graph looks like the way it does. You don't need to be terribly accurate. Like, I mean, you don't need to put points. If you want to put points, go ahead. You can. But it's good enough to sign chart. It tells you what to do. Of course, x-intercept, y-intercept's good. Don't cross x-axis again, because you have more x-intercept than not supposed to. Don't draw some weird squiggly stuff. Like, make sure you're using the asymptotes as guardrails. Very important. Okay, we're all good. All right, that was a very thorough review of the homework. Now let's do the notes. Any other question about homework before I move on to the notes? No. And the soccer players, Addie and Laura, what time do you guys leave again? Oh, yeah, that's right, your shoulder. Laura, do you want to
Finish the lesson.
Okay, good. Very good. All right, then I love it. Great. Okay, all right. Love the dedication to math. All right, so let's get to notes in. All right. Notes are very short today, which is kind of good because you guys have had a long day already, right? Actually, come to think of it, you guys have had like nearly 5 hours of school. That's a lot. That's too much, man. All right, here we go, guys. So let's talk about power functions. Go to page 3. Middle of page 3, please. Thank you. All right. Excuse me. Okay, a power function. I think you guys this should be somewhat intuitive. What kind of function am I dealing with here? I'm dealing with k, which is a constant, x, which is my variable, my input, a, which is another constant, happens to be an exponent. So we call this a power function because you're raising x on power, right? Now, we're going to start looking at, we're going to generalize this in such a way where our exponent could be any real number. It could be positive, it could be negative, it could be a fraction. And it's going to behave differently depending on what we have. There's going to be a range of values we're going to look at and generalize in such a way. For example, if a is like bigger than 1, there's a certain way we look at it. If a is between 0 and 1, there's a certain way of looking at it. If a is negative, there's a certain way of looking at it. Also, k, this negative, that's going to cause a reflection, right? About the x-axis. So we're going to have to look at that as well. So go back to the beginning of the definition of a polynomial function. Let's not worry about that. But are all some or no power functions to be polynomial functions? Some are, some can be. I'd say some for this one. For example, what if you have y equals 2x squared or 2x cubed? That's both a power and polynomial function, right? Even though poly means many and 2x cubed is a monomial, it still counts because you have an integer, non-negative integer for your exponent. But what if I showed you this? Is that a polynomial function? No. That's just a power function. Or let me do one over here. What if I do y equals 2x and negative 4 power? What kind of function is that? Is that polynomial? No. It's rational, but it's still power also. I shouldn't say just power. It's not polynomial, put it that way. It's let me rephrase that. I don't like the way I phrase it. Power, not polynomial. And that's power, not polynomial as well. Are you guys focused on math? Okay, good. So I'll make sure. All right. By the way, this will be a radical function. And again, that was a rational function. Okay, I might be getting a little ahead of myself, but hope that makes sense. Okay, so let's move on to the bottom of the page. And it says sketching them. Okay. When you sketch them, there's it takes on one of 4 basic curves. I'm going to show you that in a moment. I'm going to generalize this for you guys. And we've really focused on the first and fourth quadrants. But we also are going to take a look at the left side as well, like the second and third quadrants. We're going to take a look at that because it is important to consider. Yep. So let's talk about it. Okay. So there's a possibility that A is 1. There's possibility A is bigger than 1. A is bigger than 0. Sorry, less than 0. Or A is between 0 and 1. And so these are the 4 categories. So let's take a look at y equals x. That's pretty, and I'm going to color code this. Hopefully the colors show up nicely. Okay, does that make sense? Yeah. Okay. So that's linear, obviously. Okay, let's do y equals x squared. Let's go dark green. So that's quadratic. That looks like this. Is there a left side to it? Yes, there is. I kind of missed, but you get the point. Okay, let's go red for this one. That's a rational. So it's going to look like this here. And lastly, we'll go blue. That's a radical. Will that have anything to the left of the y-axis? No, right? Yeah, it's not defined for that. Okay. So all functions pass through what point? 1, 1. When k is bigger than 0, all 4 have graphs that lie in the first quadrant and exhibit the 4 possible shapes. So what are the possible shapes? There's this, there's this, there's this, and there's that. So those are 4 possible shapes. Some of the graphs have functions that lie in the second and third quadrants, and that just depends. on domain. Right, that depends on domain. Okay, questions so far? All right. So let me look at the homework again, see what you guys want on the homework. All right. Yeah, we got some good ones here. Okay. So let's do this. Before we do the bottom of these notes, I really need to kind of look at my AP calculus stuff. Give me a sec here. You are going to do AP calculus in the spring with me. I'm going to use my AP calculus notes, guys. Not right now, but no. This is another. Let's see here. No, hold on. Oh, awesome. Here we go. Just done that. Actually, hold on. Awesome. This is exactly what I want to pull up for you guys. Okay. You guys don't have this. That's okay. I'm just gonna walk you guys through it. And I'm gonna you don't have the sheet. I'm just gonna walk you guys through it. Okay. I'm gonna do this on the board too. Take a look at that's 6. 45, 6. Okay. That's x to the 5/3, by the way. That's x to the 5/4. Okay. So does this pass through the origin? If I plug in 0, what do you get for y? Well, we're doing number 5, by the way. If I plug in 0 for x, what was y equal? 0. 0, good. Okay. Now, let's see what the general shape of it. Your exponent's bigger than 1, right? It's gonna be kind of like a parabola. It's gonna be like. These are not in the notes, guys. They're not in the notes. They're not in the notes. Don't bother with them. Okay. So we expect that to happen, right? Okay. Same thing here, right? This passes the origin. If I plug in any value bigger than 0, like say 1 or 2 or 2.5 or 3, whatever. I guess something like this here. Okay. Now, this part's a little tricky. Can I plug in negative numbers into this? Perhaps. No. Of course I can. I can keep with negative numbers. But can I plug in negative numbers into this? No. No. It looks like that, and that you just leave alone. You didn't touch that. You leave it alone. So like if I go to Desmos right now. Y equals x raised to the 5/3. Oh, I messed up, guys. I screwed up. I'll fix that in a moment. Sorry, guys. I always mess up with you guys. Okay, I was right about the second one. Okay, why was I wrong with this one? Let me go back to the worksheet. Yeah, I messed up. If I plug in a negative number here, what's cube root of -1? And then what's -1 to the 5th power? Still negative. Yeah, sorry. Actually, what I should have said was this. Is this an odd or even function? That's what I should have said. You guys remember that? It's an odd function because if I replace x with negative x, the output becomes negative. Now this one, it doesn't really matter because you can't pour through negative numbers. Let me show you another one here. Let's look at 3. Let's compare 3 and 5 really fast. So let's look at 3 really quickly here. For number 3, okay, is that bigger than the one that exponent is? Yeah. Okay. So I expect the general shape to be that. Now, you're cube rooting and it raises to the 4 power. So you can plug in negative number, that's fine. But if I plug in a negative number for x and it raises to the 4 power, it's an even function. Yes. Now it looks like this. So notice that we have to really consider whether the denominator is odd or even, and if the numerator is odd or even. If the denominator is odd, the domain is all real numbers. If the denominator is even, it's not all real numbers, just x is greater than equal to 0. And then if the numerator is even, you can have an even function. If it's odd, you have an odd function. So you have to look at the symmetry as well. So you have to really think carefully about these. And this is a big part of calculus because you're gonna be doing a lot of stuff with this, a lot of functions like these in calculus. Okay, let's look at 2 and 4 really fast. Let's figure this out really quickly here. Okay, for 2, I need to erase 4 too. Okay, for 2. Okay, that exponent, is that less than 1? Yeah, 100%. That's 4/5. Okay. That's x of 4/5. Okay. So it's still passed through the origin, but generally it's gonna be like that, right? It's gonna be kind of like a square root function, right? It's like y root x. Now you're in the 5th root of x, then raised to the 4th power. Okay? If I domain all real numbers. It is. The domain's all real numbers. So I can plug in negative numbers, that's okay. Now look at your numerator, that odd or even. So when I plug in -1 here, it comes out as being still positive. I think it's similar to the left side. Let's go like that. I know, weird, huh? Now what if that was x is 3/5? It'd be like that. It'd be like a cube root function. Yeah, that's kind of funny. How it does that? And those things matter. They matter tremendously in the first semester of calculus. Let's look at x at 3/4. I'll do it right here. Okay, so can I put in negative numbers with that? No, right? That's it. Leave it alone. I can't plug negative numbers. You can't pour through negative numbers. Yeah, so it still just looks like that. So it's not defined for x less than 0. Let's do negative numbers really quickly, negative exponents, and we'll then just move on to other stuff. Okay. So this is 1 over, right? That's 1 over x to the 2/3. That's 1 over x cubed. Okay. Well, I kind of expect to look like this, right? Expect that to happen. Because whenever you have a negative exponent, it's going to be like a rational function. Now here's the deal. If I plug in negative numbers, you have to positive or negative. Positive. Look like this. It looks like that because you have to guarantee a positive outcome. Positive outcome. Here, it's gonna be this, and then this. But what if I decide to do that?
It'll go back.
You can't 4th roots, negative numbers. See it like that. Also, if I put a negative out front, what's gonna happen? It's a flip, right? If I put a negative here, that flips. So the homework's gonna be a lot of stuff like that. Let me go back to finish off the notes, and then you guys, yeah, and just to go back to Desmos to verify. So like if I did negative 2/3, yeah, see, I get that. Or if I put negative 3/4, but if it is just negative 3. So, all right, let's go back to notes. All right, let's do part B, finish it off. Here we go. Okay. So let's go kind of like maroon, then green. We'll go dark blue here. We'll go red for that one. Okay, so if A is 1, it's still linear, right? Easy peasy. So linear. Now negative 2x cubed, remember, it has to be reversed. So it's going to look like this. Actually, it's crossing at -2, by the way. And 0. So we kind of expect to kind of do this. And then for the blue, that's x at negative. Is that -1/3? -1/3. Okay. So expect to kind of do this kind of shape. And lastly, if I plug in 1, I should get -2, 1, -2. I kind of just eyeball the other ones. And then here, start here. Let's go red. Yeah. So expect it to kind of look like this. So they all pass through 1, -2. So all of them are in the 4th quadrant. They have those shapes I just showed you. And some can be in the 2nd, 3rd quadrant. Depends on domain, right? Okay. I think that about covers it for today. I probably should have printed that worksheet. Maybe, what I'll do is maybe let me print that worksheet, power functions that I just did, and the answer key, so you guys have that as an extra guide to help you. So you could add this to your notes. Homework is just going to be this. I'll post the schools in a moment. You're going to be working on pages 9 through 11, I think. Yeah, so 9, 10. Sorry, 9 through 12. So 8 problems, 1 through 8. That's what you guys are doing today. There we go. And the answer key's up in schools. You can check it out.